Example number 8 asks us to differentiate this ugly function over here. So what I'm going to do is I'll call this guy y, and then I'm going to use a technique for taking the natural log of both sides. So and the reason I can do that here is if you look at this function, the numerator is always positive. And let's check that out. You're always squaring something. Even though you're taking the third root, it's getting squared at some point. So this guy should be positive. And the bottom, of course, we know that that's positive. So if you take the natural log of both sides, we shouldn't have an issue. Now we know to differentiate here, this gives us dy dx times 1 over y. Now this side over here, we're going to go ahead and differentiate it. But we're going to use our log here to split this guy up and play around with it a little bit. So the first thing I'm going to do, let me do some reduction over here on the side here. So this is the natural log of 2x plus 3 to the 2/3 minus the natural log of the square root of x squared plus 1. And this guy is 2/3 the natural log of 2x plus 3. And this is minus 1/2 the natural log of x squared plus 1. So let's go ahead and put those guys in here. So it'll be 2/3 the natural log of 2x plus 3 minus 1/2 the natural log of x squared plus 1. So this gives me dy dx is equal to y times. Now, we got to take the derivative of each of these guys separately. So this is going to be 2/3 d dx. So I'm going to go like this, of 2x plus 3 minus 1/2 d dx natural log x squared plus 1. Okay, now y is equal to this ugly mess. We'll put that guy in there later. So let's just put it down here for a minute. Excuse me. So this, the derivative of this guy right here is going to be, so I'm going to get 3/2 times, now it's the derivative of the inside over the inside. Now think about why that is. I used the chain rule here, but you should go ahead and justify that the derivative of this is equal to this right here. Then minus 1/2 times 2x over x squared plus 1. So this is going to be y times, now the 2's cancel out here, so I get 3 over 2x plus 3, and this is going to be minus x over x squared plus 1, like that. Okay. Now, once I'm here, I'm going to, let's see here, what do I want to do? Well, we can go ahead and plug what y was back in here. So this is going to be equal to, it doesn't hurt, this will be equal to 2x plus 3 to the 2/3 over the square root of x squared plus 1 times this guy and then times this guy. So let's just do those separately. So this will be 3 over 2x plus 3 minus that guy again, so 2x plus 3 to the 2/3 over the square root of x squared plus 1 times x over x squared plus 1, like that. And so if we continue, we have move this guy up, okay, or you can think about it like moving this guy down. It's fine either way you want to think about it. We do have close to, or excuse me, we do have, let's take a look at our denominators here. We're going to eventually at some point combine these guys together. So if we move this guy down, that'll give me 5/3, okay, down here at the bottom. Or if we move it up top, okay, I'm going to have the following. I'm going to move it up top because I'm going to have 3 times 2x plus 3, so 1, so this would be negative 1/3 over the square root of x squared plus 1, and then minus. Now if I put these two guys together here on the top, I'm going to get 2x plus 3 to the 2/3 times x over x squared plus 1 to the 3/2, like that. So what I'm going to do here is I am going to, let me see here, what do I want to do? Well, honestly, it's really not worth doing a whole lot of simplification from here. I mean, we can combine these guys together, multiplying top and bottom. It's just a really big mess right now. So, and that's fine. We can just leave it like that. If you want to, you can follow the book. They combine this guy right here, and then they just multiply it by top and bottom of what y was. And so you can do that as well if you want to, but it's really irrelevant. Getting to this point or this point, that's you're in good shape.